Now, not all bar graphs are good bar graphs, and that's what we're going to learn in this lesson. So let's take a look at this bar graph here. If I take a look at it, the bright red bar is popping out at me, and the title is Massive Massive Increase in House Prices This Year. Yep, sure looks like it. In 1999, the house prices skyrocketed to $82,000. But let's take a closer peek at what that increase actually is. It only jumped $2,000. So yes, there was an increase. It was $2,000. And it might seem like a lot of money, but not when you compare it to the actual price of the house. If we compare that and calculate it as a percentage, it's 2,000 divided by 80,000, which equals 0.025, or 2.5%, because we're going to move this decimal over 2 spots. So it's an increase of 2.5%. Is that a massive increase? I don't think you could qualify that as a massive increase. So why does the graph look like it's such a big difference? It's because of the scale. It didn't start at 0, it started at 79,000 actually, and went up from there. This is what the graph would look like if we plotted it from 0. So notice that it's just a sliver above the blue line. And so there's a slight increase, not a massive increase. So the question is, which graph is more appropriate? Well, if you want a true picture of what's happening, I would say the left one is the most appropriate, because there was a slight increase and we can see it. This exaggerates the increase. And there might be reasons why you want to do that. A real estate agent might do that, but to show that the properties in a certain area are climbing dramatically. But they're trying to mislead you by doing that. So when you look at bar graphs, be careful to watch the axes to make sure you're actually reading the information correctly and you don't just concentrate on what the picture looks like. So let's take a look at this graph. It sure they've added a little bit of extra to it by making it 3D. It kind of pops out of the page and makes it more interesting to look at. And it definitely looks like 1995 has the highest number of singles. But if you were to draw this line back in a straight line because of the perspective drawing, they're actually not that different. They might even be the same. So that massive increase that it looks like it has, it actually doesn't. It's an optical illusion. And the other thing is that the axis has no numbers on it, no scale. And so that means that the information, we don't know how many singles were sold in 1995. So no idea. When were the most singles sold? In 1995 or in 1997, but it's hard to tell from this graph. If we used a more traditional form of the graph, a flat graph, a 2D graph instead of this 3D, this is what the information would look like. Notice now we've got scale on the axis too. So by looking at it straight on, we can see that in 1995 and 1997, they have the same number of singles sold. And it's approximately, if this is 10,000 and this is 20,000, I would say, and this is halfway, maybe 160,000 approximately. So when did they sell the most singles? In 1995 and 1997. And how many singles did they sell in 1998? So in 1998, they sold, I'd say, about 50,000. So this graph gives us way more information than this one. But you can see why this is an alluring thing to present if you really want to show that in 1995 they had a fantastic year. But it is misleading.